We were talking about functions and their graphs, and the example we had yesterday was actually had a graph that we looked at. Well, what if they don't give you a graph? What if they give you a function like Section 1 did? So this is a lot like Section 1 in that they give you an equation and ask you to find that domain of that. So that was the main focus of Section 1. So how do we find the domain of that particular function there? Yeah, real simple. Set x plus 2 equals 0 because it's got the red flag of x in the denominator, and solve that. So x cannot equal -2, right? So we write that x does not equal -2, and the interval notation would be from -infinity to union to -2. Yeah, -2 to infinity. X such x does not equal -2, and then -infinity to -2 union -2 to infinity. So domain, same as Section 1. That's nothing new. So when we start talking about in relation to the graph, they say, okay, well, what about this ordered pair? Is the ordered pair, bless you, 1/1/2 on the graph, bless you, of f of x. So how do we determine if an ordered pair is on the graph? What are the ways that we could do that? Say it again. Plug it in. Plug what in? Yeah, perfect. That's a great way to test it. Take the x value, plug it in, see if it works out to be that y value. If it does, then is it yes or no? Yes. If it doesn't, then it's obviously no. So let's do this. Find f of 1. Function value 1 plus 1 over 1 plus 2. That's 2/3. That's definitely not on the graph. Out of there. So really, really simple. It's just function value. They're asking, okay, well, when x is 1, what's y? We think it's 1/2. Is that on the graph? That's one way to test it. What's another way? This is the way I like the best, but there are other ways, so I want to talk about it. You could actually graph it with your calculator. You could type this equation into your calculator. Just be careful that you put the top part in parentheses divided by the bottom part in parentheses if you're going to type that into the calculator to graph it. And then you could check that. So let's let that load up and we'll show that real quick. And then we'll go from there. So when you're graphing with the graphing calculator, there's a couple of different options, especially if you've got the newer color ones. If you've got the other ones, it works the same way. It's just there's some options there. So when you go to the y equals menu to graph that, I'm just going to clear out this stuff we were doing the other day. And one way would type it in is parentheses, and then you're doing x plus 1. Close the parentheses, divided by, and then open up another set and do x plus 2. And you hit graph from there. Okay. And you get this picture. And then the way you could test that point, one of the ways would be go to the table and type in a 1 for x. We did that in Algebra 2, or my classes did for sure. Or you can hit the trace button. We use that some too. And then just type in a 1. And we get that y value. That's not 1/2, right? We know that that's 2/3. So we know that that means, oh, here's the x value, here's the y value. They don't match what they ask us to find. So we know that's not on the graph. So there's another way of testing whether a point is on a graph out of that. All right. Easy thing there. So part 3, a little bit more difficult. Where is f of x equal to 2? What do you do? This is similar to number 2, but not exactly the same. How can you find where it's equal to 2? Okay, let's look at the graph. So what is that asking us to find? Y being 2. So we've got to look for where is y 2. It's over here. So if I look on my axis, up to 2, and then I've got to go over here. It doesn't look like it's a good spot, does it? That'd be very difficult. If I hit trace and then move my cursor to the left a whole bunch and try to get where y is 2, that's pretty close to 2. Not quite 2 for y. And my x value there, that's close, but it's not exact. So that's no good. Good idea, though. Great idea. It is. We're looking for that spot where the y value on the graph is 2. How can we do that algebraically? Okay. Set it equal to 2. Absolutely. Set x plus 1 over x plus 2. Instead of plugging in x like we did with part 2, we're actually plugging in the y value because this says when is y equal to 2. So setting that equal to 2. How do we solve that? Good old proportion style. Yeah, if we multiply by x plus 2, it'll give us x plus 1 is equal to 2x plus 4. And solve that for x. Bunch of different ways to get there. I'm going to do it this way. It's going to be -3 is equal to x. So where is f of x equal to 2? It's when x is -3. Does that make sense according to our graph? Yeah, we could trace and get really close to 2 on the y-axis, but we couldn't get exactly that when we were doing the trace. So, but we knew it should be somewhere around -3, right? So that can help us get to the right spot there. So definitely the right way to do that there algebraically. Not always is it going to work out to be a nice number there. So that's why the algebraic method is going to be better than using the graph. Graph's going to work sometimes, but it's not going to be an every time kind of thing. All right. Next thing is the intercepts. So what kind of intercepts can we have? X intercepts and Y intercepts. Doesn't matter what order you find those in. We're just going to find them. Okay. I think Y intercepts are easier. So I'm going to find those first. How do you find Y intercept? Yeah, see where it crosses the y-axis? Or plug in 0 for x, right? Should be 1/2. So the y-intercept is at 0, 1/2. If we look at our graph, look where it's crossing the y-axis right there. You can hit trace 0, and it gets right on that spot. And, that's 1/2. That's what we found algebraically or by plugging it in. So same thing. So it should line up with what the graph's doing with what you're finding by plugging in the numbers out of that. All right. How do we find X intercepts? What do you mean reverse? I think I know what you know what you're saying, but not quite. Almost. Put a 0 in for A to solve the Y. What are you going to do to get that? What Y? No. You put a 0 in. What are you going to do this time? Tell us, Hunter. Put another 0 in. For the Y. Yeah. So we got x plus 1 over x plus 2 equals 0. So instead of plugging in the 0 for x, we're plugging in the 0 in the place of y. Because on the x-axis, y is always 0. So if we're looking for where it's crossing the x-axis, y has always got to be 0. So we're replacing that. So this is similar to problem number 3 for this thing. Other than we're just finding a different y value, and they're not really. They are telling us, but they're not telling us that sort of thing. So again, how do we solve that? Yeah, if you multiply by x plus 2, what happens? It's 0, right? So that's easy. So we end up just setting the numerator equal to 0. If you remember from Algebra 2, when we were doing rational equations, we were talking about the X intercepts. We just did that. We just took the numerator and set it equal to 0 to find those. And get X equals -1, -1, 0. That's the only X intercept we have. If we look at the graph, we see, right here at -1. That's the only place this is crossing the x-axis. It's not crossing anywhere else. This one happens to have a vertical asymptote here and a horizontal asymptote there. We'll talk about those later on when we do some more stuff with rational expressions and rational functions. You may have done some of that with algebra 2, but not maybe not a ton. But we'll pick those things up. That's one of the things we'll go a little deeper with in here. All right, so that is the last example that, we only did 2 examples. It doesn't take much for this section out of that. So on page 224, 9 through 47, obviously I suggest the odd ones. Those are your my suggested problems for this particular section. So that's what I want you to kind of work on today.